Good morning, everyone. I hope things are going well at home. If you're like me, you're starting to miss seeing people's faces, but hopefully that will happen again soon. At least we have some math to help us through this. And what we are going to be doing today is we're going to be looking at not the centers of triangles, but a few other special qualities within them. And what we're going to be looking at is how the sides and angles of triangles relate when we're looking at inequalities. So let's take a look at that with this triangle here. In this triangle, we can clearly see that the sides and angles are different measures, and that's because this is a scalene triangle. And what we're going to be doing, though, is looking at how that bit of information can actually help us understand more about the sides. So let's start with this. If I'm looking at my angles, I can see that angle C is going to be the smallest. I can see that angle B is going to be my second smallest, so that's going to be my middle. And I can see that angle A is my largest. And now normally I can't trust a picture, but in this case, I'm going to assume that this is accurate, that all the measures are exactly what they look like in this picture. So I have the order of the angle measure from smallest to largest. And if I'm looking at this picture, I can also do the same thing with the sides. So let's list the sides from smallest to largest as well. If I'm looking at my smallest side, I can clearly see that my smallest side is AB. Well, my next smallest side, if I'm looking through this, is going to be AC. And last but not least, my largest side is that final side that I haven't talked about, unsurprisingly, and that is BC. Now, you might look at these and just go, okay, well, that's great. You've counted the sides. People have been doing that for ages. We've been doing that since we were little kids. And that's actually accurate. But there's actually a neat pattern that pops up here. Notice how when you look at AB, the smallest side, it's opposite to C. And C is our smallest angle. Notice also when you look at our middle, angle B, that is opposite of the middle length side. And last but not least, our largest angle is opposite the largest side. Now that's pretty neat because that means that these correspond. And this is actually pretty logical if you think about it. Because if you're looking at a triangle formed by two random objects, you can kind of see as the triangle is formed what it's doing to the opposite side. So let me show you that just one second. So let's say this is our original triangle. You can see that this angle A corresponds with the side CB. And A is not a particularly large angle at this point. But if I increase the measure of A, if I made it larger by just, expanding it out, notice how that side grows as well. As A gets larger, so does the length of CB. And I can keep going and going and going. I can make A incredibly large. And as that A grows, so does that length of that opposite side CB. And the reverse is true. As that A shrinks, if I made it smaller than the original, CB gets smaller and smaller. Therefore, the larger the angle, the larger the opposite side, and the smaller the angle, the smaller the opposite side. And we can even reverse that. And we can say, well, the larger CB is, the larger its corresponding angle will be. So if I made CB larger, as I pull this side away, right, I'm making this last side come wider so that CB can be larger, I, of course, then also make A larger. Now, it's a pretty simple concept, but it is something that comes into play in geometry. And a lot of times what we think about this with is in terms of length or distance away. But for now, let's just practice the concept itself and see how that goes. So what we're going to do to practice is just take a random triangle and we're going to list the angles in the triangle in order from smallest to largest. And now, of course, this one doesn't have labels and everything's a little bit easier with labels. So let's go ahead and label this. And I'm going to do A, B, C because that's kind of our traditional triangle. Now, if I wanted the angles from smallest to largest, I know that my smallest angle is going to be opposite the smallest side. And since this right here is my smallest side with a measure of only 9, that means the opposite angle, the angle that's not touching it, is going to be the smallest. So that would be angle A. I can even cross it out if I want, because I know that that angle is taken care of. Next, I go ahead and list my next largest side, and I find the angle that's opposite it. So my next largest side is AB, and the angle opposite it, not touching it, is C. So that means my next largest angle is angle C. And of course, that means I only have one left. So if I look at my largest side, sure enough, the opposite angle to that is angle B. And I now have my angles from smallest to largest. And I can use that same process, but in reverse. I can list the side lengths of each triangle from the shortest to the longest. And here, notice how I have each of my angles listed. What I'm going to do is, if I want the shortest side first, what I'm going to be doing is starting with my smallest angle. And in this case, my smallest angle is B, which means that the opposite side will be the shortest in length. And never trust the picture. Even if this picture turns out to be reliable, don't trust the picture. Sometimes the sides are going to look the same or smaller or larger, but all you can really trust are the numbers written on them, okay? So AC is my smallest side. My next smallest will be my next smallest number, which is angle 60, and the side opposite that is BC, so that will be my middle or next smallest side. And last but not least, my largest angle is going to be opposite the largest side, which is then BA or AB. And I have all of my sides. Now, of course, there are special situations. Let's say that I gave you this triangle. And I told you that in this triangle, this has a measure of 30, this has a measure of 30, and this has a measure of, well, what would it have to be if the whole thing adds up to 180? Well, this would be 60, so that means 180 minus 60 would be 120 along that vertex angle. Now, if I'm saying, okay, list the sides from smallest to largest, you might notice a problem. 30 and 30 are exactly the same. Well, we know that 30 and 30 are the same, and that means that this must be an isosceles triangle. And it has to be isosceles because isosceles triangles have two base angles that are congruent. That means the side AB and CB are going to be the same length. However, I also know that this picture is super unreliable because my largest side is going to be opposite the largest angle. So that means my largest side is actually AC. So if I was going to list my sides from smallest to largest, I'd actually have a tie for smallest. Smallest is going to be AB, which is actually congruent to BC. And my largest side is going to be the one opposite B, because B has the largest angle, and that is AC. Again, do not trust the picture, only trust the measurements written on it. So that would be the case there, which means that when you have triangles with all equal angles, you will have triangles with all equal sides. Those are equilateral triangles. Those are special situations, though. For the most part, you will be dealing with scalene triangles because that's where this comes most into play. Go ahead and solve the problems on page 224, 1 through 13. Don't forget to solve for missing angles when you need to. With this one, it is quite hard to show your work. The only ones that you'll really be able to show much detail on are the last couple when you solve for that missing angle. Please include that formula. Upload that today to Classroom and you will be done. I hope you guys are having a great time at home and enjoying kind of the different formula for school. Have a great day.